In this video, I will speak about the commands under commands menu, and also I will speak about creating new material definition and how to assign this new created material to the members, plates, to beam members, plate members, or solid members. And there are some disadvantages of using this program in terms of solid elements, for example. And then I will speak about some modeling mod menu, and under mod menu we have modeling tab and also post processing tab. Since I haven't done the analysis, I haven't performed any analysis, I don't have any results in the database now, so I can click on this tab, post processing. Now let's continue. As I said at the beginning of this video, or the record, I will speak about the commands under the command menu. Now, plate thickness, surface thickness, member property, all those things, all those commands can be reached from property page, or instead of property page, let's say from modeling page. From modeling page under geometry, the property page can be reached also. So also I recommend those things are frequent to use icons or the commands. They can be reached by means of clicking on the toolbar, but to memorize how those commands are, from which places the user shall reach these commands and properly in the required order, it's better to learn to use this modeling page. From here, I will come to the point that plate thickness, surface thickness, which we use to define the thickness of a surface, which is a shear wall, thickness of a plate, which is a floor, okay, and some material and cross-sectional properties of a frame element. Here in Staad Pro, frame element is referred to as beam element, whether it is a beam indeed or a column. The material constants, and I also suggest don't use any of those commands. I use them. It's nonsense to use those commands, and they bring nothing to us. I will show another way, and I recommend not to use especially those here given commands regarding material constants, the geometric constants, or instead of using also the commands here, I recommend not to click on any command, not to reach any command from commands menu, but instead using modeling tab or modeling page. By this way, the user will not confuse, and in the regular order, the user will be accustomed to use the required commands from the modeling page. Maybe this define damping for dynamics. This can be clicked here. Here the user, you know, every structure has free vibration modes, and all in those free vibration modes there is no damping. But in response spectrum analysis, we structural analysts assume some damping for our structure, and then combine those free vibration modes, and then combine the results coming from these free vibration modes of the structure by means of some rules, SRSS or something like that, and then obtain a result. When we apply this response spectrum analysis or something like that, we may assume damping for every mode. For example, generally for if I do not make a mistake, for concrete structure 0.055% is the general damping ratio. For steel structures, it was, if I'm not making a mistake, it was 3% or 0.03. So one can write here explicitly for every mode a damping ratio is written. For example, assume that my structure is composed of reinforced RC elements, reinforced concrete elements. I write here 0.05, for example. For every mode, 0.05. Okay. This is my idea to how to fill the model damping ratios to here. Evaluate means the program uses a formula to calculate the damping ratio of modes. I didn't read its theory, but if for reinforced concrete structures, the general damping ratio is 0.05. You can also write 0.05 to here, and then click OK. This is the basic simple solution of you entering the model damping values for RC structures from my point of view. Okay, say cancel. Under commands menu, this, if you will make a dynamic analysis, I mean response spectrum analysis, or some other, I don't know, maybe time history analysis can be done with Staad Pro. I didn't learn anything there about analysis types of Staad Pro. I know that linear elastic analysis is done with it, and some buckling and some free vibration analysis can be done, and geometric nonlinear analysis can be done by this also. But I don't know their details. I will learn and speak about those things later in the later coming videos. So this is also not required. You can reach all these commands and arrangements, or all these subcommands from modeling page. This is also not required. This is also not required. Miscellaneous, there are some commands here. So under commands menu, just you may use, if you will make a dynamic analysis, you may fill model damping ratio. Okay, for your free vibration modes, you can enter damping ratio, not the damper constant of dampers, but corresponding to every free vibration mode, you have to enter damping ratio. Okay. So that might be here might be clicked by the user, and under miscellaneous some to some sub commands can be clicked. For example, input width. What is the meaning of that? 72 columns, 79 columns. They are easy things. Many of things are standard, and changing the parameters using these sub commands will bring you nothing. So better also not to click any of them. Here there are explanations of those sub commands. If you click miscellaneous sub menu, I will reach this window, input window. What's the meaning of this? 72 columns means 72 characters per row in the input command file. We use input command file. You can edit input command file by means of any editor or using the default editor provided by the Staad program. And instead of using graphical user interface, by means of an editor, you can create your model, you can analyze it, you can also extract some results after analyzing. Opens the input with dialog, which is used to set the maximum allowable number of characters per line in the input file for processing. Input file. I think there's no difference using 72 characters or 79 columns. Better don't touch it. Output width. This is the character per row entered to the output file or provided by the output file. It doesn't matter instead of 72 columns or 118 columns. For me, it's better not to touch anything. Default value is okay. But if you change from 72 columns to 79 columns or 72 columns to 118 columns, everything's okay. No problem will occur. Opens the output with dialog. I think no easiness will be provided if you make any change also here. Opens the output with dialog, which is used to set the maximum allowable number of characters per line in the output line file. Sorry, you know what is input. This is our input file. Okay, and this is our output file. I can't now open my output file because I didn't make any analysis, but remember from the previous records videos of me, what is the output file? Okay, now can I perform run analysis? Okay, two warnings and view output file. That's the output file. Okay. If I increase the number 72 from 118, so there will be more, the length of this row will be longer. That's will be more. That's the difference. I think it brings no easiness, or it will make nothing more easy or beneficial for me. Better not to touch anything. So many of the commands, sub commands, reached by clicking here under the sub command miscellaneous under commands menu. Will bring me no benefit. For example, ignore list. This command requires no additional parameters at command. Used to enter member list specifications without having to worry about non-existent member numbers, if any. In the absence of this command, and a non-existent member in the list specification will generate an error message. And message dialog opens to confirm the addition of this command to the input file. Click yes to add the ignore list command to the Staad input. It means that if in the input file there are some member numbers, but anyway they do not exist. I erase them or because of any reason. But this will create no error, but it's false. So the number of n members shall not exist in the input file since they do not exist in reality in my model. But because of that, the program can give me some warnings. It says this command requires no additional parameters. Add command means that if you say yes here, if you say yes, this means no. They are in Turkish. If you say yes, ignore list command will be added to the Staad input file. Staad input file. If you say yes, means that if non-existent member numbers do exist in the input file, there would be no problem for us. This mistake will be ignored by the program. It is also not important for me. It's also not. You can say yes easily. Check source story used for analysis of seismic load for Indian standard 1893 code in Indian. If you are making a structural analysis for according to Indian standards, you can use this check source story command under miscellaneous. Okay. Maybe it's a check which is made by the program. Not only as I understand from you, not just for Indian standard, for American standard ASCII 7, a source story check is made by the program. Okay, a source story check is useful for me. If the program controls my structure and no rigid floor diagram is presented in my model, so there is no need to add this command to the input file. That's logical. Okay. So under miscellaneous subcommand, under commands menu, check source story can be used, and it has this meaning. Set NN dialog box is used to specify the maximum number of primary load cases for processing. It's not required to enter any value here. Don't care it. Set echo. All the text in the input command file is written to the output file if echo is on. I think it doesn't matter if all the text in the input file command is written into the output file or not. You can click here if you want to see input command file text in the output file. You can click on echo on. If not, click on echo off. Set Z up. This arrangement can be done from the configuration panel, as you all know. We can set instead of y-axis, z-axis, the vertical axis. You don't need to make any change from here. In the introduction video of this video playlist, I have shown this. Set displacement. There is a tolerance is right here. If the program make any nonlinear analysis, geometric nonlinear analysis, P delta analysis or some other type of geometric nonlinear analysis, then the program recalculates the displacements, or recalculates an indicator which whose value depends on the displacement values, or yeah, the displacement values. This tolerance, if the difference after two solution in a nonlinear analysis is in the tolerance is smaller than the tolerance value, or is in the convergence, so the program stops making new iterations, finding new solutions, and the last solution's results are accepted as the final result. However, you don't need to enter any value here. The program calculates the correct value. Don't enter here any value. Opens the damping ratio to be used for all springs dialog. Which allows damping property of springs to be considered in computing the composite model damping for each mode in a dynamic solution. Damping ratio to be used for all springs dialog. Damping ratio for all springs. I don't know, in real structures, reinforced structures and steel structures, I don't use general springs in my analysis. So I don't know to estimate this damping value used for springs. I have no idea about this. In technical reference manual, some information may be provided here, but I didn't read it. I think it's also not required. Yeah, this similar thing is written here. I don't think that this is required. Set warp. Open the warping restraint ratio to compute torsional rigidity dialog. You know there is Saint-Venant torsion and also the non-uniform torsion, which allows end warping restraint to be considered for I-shaped members. Details are available in section 5.5 or the Staad technical reference manual. Okay, assign a value which is in range 0 to 1. 0 indicates no restraint, 1 indicates full restraint, a fraction indicates a partition restraint. Okay, this is meaningful. If your I-beam is restrained against to warping, I mean the cross-section warping is prevented by means of the support conditions. Okay. So, no warping takes place. It's restrained. So enter 0. Enter 1 for the full restraint. Enter 1 for the full restraint. If there is no restraint means maybe I'm telling wrong. Now I will try to explain it by means of figure. If I do not know, maybe I can also tell wrong. Okay. Warping. You know what warping is? For example, for this cross section, warping. This flange is bent. Top that. So that. This flange is bent. With the web of the I-beam, we have no problem. As you see, the bending moment is at the top flange is so. Okay. And now think that the bending moment at the bottom flange is so. So the resulting bending moment is zero, caused from warping of the cross section. And in this condition, bottom flange makes such a displacement bending. Now, if there is restraint, means that the flange is attached to any wall, for example, and either the pushing of the for example, now think that there is a wall here, or anyway the flange is top and bottom flange are anyway glued or bolted to the wall. Top and bottom flange, the cross section do not make any movement into the wall or out to the wall, out to the wall. Okay, this means that it is fully restrained. It is fully restrained. When it is fully restrained, we will enter here 1. Instead, it is full restraint. Okay. When it is not restrained, means that anyway we fork, they say fork support, like a fork, support. Okay. The flanges, top and bottom flanges, can make those deflections, because in the plane of top flange and bottom flange, no restraint by any wall or similar like that can be applied to the top and bottom flanges of the beam or the member. Okay. Now, in this condition, since the warping of the cross section is warped, and the warping is not prevented, so the cross section doesn't remain as plane, it is warped in this condition, so there is no restraint against the warping. Then if there is no restraint against the warping, in this condition you will write 0 here. Okay. For I-shaped members. But that's okay. This is also not important. This command is used for omitting the additional pull, shear, distortion, stiffness term in forming beam member stiffnesses. With this command, you can exactly match simple textbook beam theory results. The results obtained provided by the program is, I think, enough accurate for us, but you can use this command to take into consideration the because of the shear distortion of the beam members. This command opens the maximum number of tension compression iterations dialog. You don't need to enter any maximum number of iterations to the program. This is also not required. You can suppress the warning message in the program, or you can let the program send you warning message in the output file. Depends on you. You can suppress or not. You can use this command under this command in the commands menu under miscellaneous subcommand. This is also not required. This is about calculating the model vectors or free vibration analysis of the structure. Better not to change anything here except the default values. Cutoff mode shape. The maximum number of mode shapes can be specified here. Other things are not important, but you can the program Staad normally calculates first 6 modes, but sometimes it's better to write number of modes more than 6. Maybe any mode not included in the first 6 modes might be important for us to catch these modes. I can write, for example, instead of 6, 10, 12, 15, something like that. Okay. Cutoff frequency opens to cutoff frequency dialog, which is used to override the built-in cutoff limit. During model calculation, response spectrum analysis, model calculation is done, the modes are calculated, free vibration analysis of the structure is performed by the program. Every mode of our structure is determined by the program, and to every mode belong to some free vibration periods, free vibration frequency, and mode shape, and blah blah blah. And after that, after the free vibration modes of our structure are calculated, obtained using these free vibration modes or results of these separated, isolated free vibration modes, using response spectrum analysis, we can obtain some earthquake-induced internal forces and base shear force of our structure, and blah blah blah, by making response spectrum analysis. And in this response spectrum analysis, we use the mode shapes and some model terms we obtained from the previous free vibration analysis. And in the response spectrum analysis, we use, in addition to these model variables, we use also some elastic design. We use some design ground acceleration, design ground earthquake acceleration graphics. Let's say graphics. When Staad program making response spectrum analysis and time history analysis, let's say, Staad will extract only those modes whose frequency is below a built-in cutoff level. So it's better to enter here a high frequency, a high value, so that the program takes into account every possible, the most possible modes. cutoff time. Cutoff time. This is used to compute the results for a longer period of time than that at which the load stopped acting. Specify the value using the cutoff time command. During time history analysis, by default, Staad calculates displacements, forces, reactions, and stresses for only up to a time which is equal to the duration of the longest acting forcing function or ground motion. Ending time for time history analysis. Specify the value in seconds. Opens the cutoff time there, which is compute the results for a longer period of time than that at which the lobes stop acting using the cutoff time command. I think this is when you're making a time history analysis, you have dynamic forces, and those dynamic forces has a period, and along this period, every dynamic force acts on your structure. For example, your earthquake load. If the period of earthquake happening, this bad event, disaster is, for example, 30 seconds. During 30 seconds, the earthquake hits to your structure, to the structure. So the duration of the earthquake load is 30 seconds. So we have to, and we will make time history analysis, and we will simulate the real earthquake by use of our time history analysis. And in our time history analysis, the earthquake load will act to our structure 30 seconds. So we have to enter here 30 seconds. So as I stated, from my point of understanding, some of those miscellaneous subcommands must be used under commands menu, and this define damping for dynamics if the user will make any dynamic analysis. If not, it's not required. Okay. The other commands, some of them are unrequired, and I also suggest not to use, for example, material commands. Not to use any material commands here. Okay. And if I neglect that command and some of those commands, instead of commands or clicking on those things, okay, under commands menu, use modeling. Okay, use modeling. Now, there is a problem using this program. In the modeling, I created my model. Okay, there's no then modeling page. First of all, setup modeling tab. First of all, setup tab. In the setup tab, these are all text things. They have nothing to do with the calculation or analysis and design. They are just information, verbal things. They can be filled by the user, those text boxes, and then saved. Okay. Under setup, we have only job info. That's that. Okay. Under modeling, I have set up geometry, general, analysis, print, design. 1, 2, 3, 4, 5 tabs. And I have to click on those 5 tabs, starting from top and going down in order. After clicking on setup tab and filling the required information to the boxes here, I have nothing to do with setup tab, and I click on geometry tab. In the geometry tab, I have information about all the nodes in my structure, belonging to my structure. Nodes of the members, beam members here. Nodes of the plate members here. I have 12 nodes, 8 nodes here. This is a solid element. It has 8 nodes, and this frame structure has 4 nodes, so I have 12 nodes, and every node number, coordinates for every node number is given here. Okay, under geometry, when I click under geometry tab, I have all those tabs. When I click here, I come here. Nodal information is always provided, and since this is beam type, information about beams also given here. Beam 1, 2, 3, 4, they have beam numbers are given here, and starting and ending node of every beam is also given here, and which material or section property is assigned to those members are also provided here. Their length and their beta angles are also provided. Can I change this from here? No. But I have information. Okay. For plate elements, I didn't do anything about it, to my knowledge. I have no plate element, no information is provided, no surface element, no shear wall. But nodal information are always here, nodal table. I have one solid, and information about my solid is provided here. Okay, it is a material number. I have no parametric model. I didn't make any mesh. By means of any mesh, I didn't produce any plate elements. So there is nothing about parametric model or mesh. If I want to make any mesh, in our previous videos we have shown how those things are done. I can do it using the commands shown in our previous videos or from here. But now I am just showing how, in which order the commands shall be used. Composite deck, this is a specific topic. I'm skipping it. Physical member, it's a design topic. We don't have physical members so far, and we haven't mentioned about physical member because we didn't make any RC design, reinforced concrete design or steel design. General, under general we have property tab, spec tab, support tab, load definition tab, and material tab. Now, in the property tab, you see what I do is I create properties. I have beam and one solid element. But there's just one problem. Now I want to use a material. Now in this program, there is one problem. The creator, the producer of the program maybe at the beginning didn't think that many versatile materials can be used with many different sections. However, we have an option, a solution which is provided by the creator of the program. I'm using it. Now, for example, here you see I will define a cross section together with any material which is not steel, stainless steel, aluminium, and concrete, which also possesses the numerical values already given as default values in the program. For example, I will use a concrete, but its elasticity modulus, its Poisson ratio, its thermal expansion coefficient, many differ very much from the default values given as concrete values in the program. I want to use this cross section with different material properties. It's still a concrete, but its values differ much from, or differ anyway, from the values provided here under the material name concrete. What will I do? What will I do? What I have to do is, okay, from this menu, from property menu, I can select the cross section. From here, from section database, okay, from many ready to use sections, but always I encounter with the problem, the material I want to use is not in this list. Okay, I don't want to use mat 1, mat 2, steel, concrete. I want to use another material and I want to enter its values to the program manually by myself. How can I overcome this problem? Here, when I click here materials, I see a table. It's not editable. I can't touch it. When I click on values, I see the values of the cross section, defined cross section here, cross sectional constants. From user table, I can obtain some if I was created before by user created table or cross section. Again, I will have this cross section with the already defined materials. So what will I do? So it's a bit funny. I can't, before using this property, there are some commands given under geometry menu. From at beam set new member attributes, you can click on here and create any material. This is one way, and then click OK, and then you will see this material name always here or here, everywhere. Another way, you will use this just to create a new material. Another way is geometry add plate, set new plate attribute. Now use material, create new material option. This is better to use. You can use this. Or geometry add solid. No, add solid we don't have. Solid does not have. Solid has material property, but this is another problem. I will tell it also in this video. Now okay. Now I want to create material 3, a new material, and use it for the beams here, and material 4, mat 4, for the solid element. And another thing, just to mention, very important here, once you created a material in this program, you can't delete it again. At least I couldn't find a way to delete it. This is also another deficiency of the program, I think, or bug, or I don't know how to do it. I'm still a learner. Command geometry add plate, set new attribute, use material, create new material. It will be, let's say, material 3 or material for beams. Let's say this is kilopascal, kilometer per square meter, as far as I know. Young modulus is 0.0 3 to 1, 5, 6, 4. Poisson ratio is 0.33. Density is, let's say, 3000. And I will not do any thermal analysis under isothermal conditions. I will make an analysis, so the temperature will not change during my analysis. So I will not need thermal expansion coefficient. There is no, it's not required to enter any value here. Type of material is not specified. It's not important. Maybe I can say that it's a special type of concrete. Okay, say it's a special type of concrete. And I have nothing to do with the compressive strength in the analysis. Strength is just to compressing, just to make comparison. Yeah, just to compare your stress results with the strength. Okay, let's say okay. Number of characters was too many. Let's say material beams. Okay, it's created and it's everywhere. Met beams. Now create another new material. Let's say met solid, and write as Young modulus, and assume that this solid is all aluminium, or don't specify any material type here. Let's write an elasticity modulus value here. Let's say 789,246 kilonewton per square meter. As Poisson ratio, let's enter 0.15, and as density, let's say 60,000. And click on OK. So I created two new materials, and remember, I will not able to erase them again. Let's say OK. Now you can find these two new created materials everywhere in other boxes. For example, I want to assign a rectangular cross section with material beam properties I have recently created. So first of all, define this. So rectangle, let's say its depth of the beam is 0.4 and width is 0.5, and the material is material created for beams. Now I can find this material everywhere. Add, as you see here, it's added here. Close. Now assign it. Use cursor to assign it. Its reference number, property reference number is 2. Okay. Now, okay, the beam has cross-sectional property and material property. They are combined here and then assigned to the beam element. Okay, but the solid element, it has no cross-section. Its shape is already determined, obvious, clear, because it's three-dimensional. It has no cross-section. It's already there with its real dimensions. When I make Where is it? Render, you see, my three-dimensional solid is already there with its real dimensions. Okay, but my rectangular beam are here now when I render the structure. But when I do not render, I see only their longitudinal axis, not their cross sections. So there is no section property is to be defined, required to be defined for this solid. But material property shall to be defined. And I defined material for, you can find this material for now everywhere. For example, here, section database, met for solid, everywhere. If you assign a thickness to a plate, met solid, you can find it everywhere. But this has no thickness, it's not surface, it has no cross section, it's not beam, it's not plate. So how will I assign met for hyphen solid to it? I have just one option. One can think that commands, material constants options can be used, but it doesn't work. I tried. I have just one option, that is using the editor to assign the new created material met solid to my solid element. First of all, you can easily understand this thing, the code you can easily understand. Define material start, isotropic mat 1, isotropic mat 2, isotropic mat beams, isotropic mat solid. Okay, and between define material start and end define material. 4 types of materials are defined, and its code is easy to understand. E means elasticity modulus, its value is that. Poisson ratio, its value is that. Its weight density has this value. That's okay. And then assign property. You see the cross section, only the cross section is assigned to members 1 to 4. Okay. The width of the cross section is 0. Rectangular cross section is 0.4. Depth is 0.5 or vice versa. I don't remember now. And then constants. Beta angle on members. Beta angle is 0 on member 2. I think this is not required. Anyway, it's added here. Beta angle. Now material mat 2 is assigned to member 5. Material mat beams assigned to member 1 to 4. It was before mat 1. Member 1 to 4, these are our my beam members, or one-dimensional members. Their material property constant. Under those constant text code, let's make it so. Let's separate here. Okay, this is not required. Let's erase it. Under constants code, here to member 5. Member 5 is my plate element. From where I know this? I can't click on this. I will show it. Met beams is attached to member 1 to 4. What is the name of material property newly created by me? Met solid. So right, met solid is assigned to member 5, which is my solid element, and met beams material property assigned to members 1 to 4. Now as you see here, assigning on the cross section, when we use code, writing code method, it's easier. We can separate assigning material and assigning section property. Just member 1-4 has section property, and the member property cross section property is assigned to them by means of this command, this text. We did it using graphical user interface, and this code is generated automatically. But this one we have to write. This also created by the actions we did using graphical user interface. But for assigning a material property to a solid, which is member 5, we had to add this line to the input commands. Okay, and then we have to save it. There is no other way to assign a material property to any solid element if we do not use our Staad editor. And specs, if we specifications are versatile. For beams we have any release, I mean hinge and some other things, offsets. We use these commands, those buttons. It's better to reach them from here. Support page can be reached from here instead of using command menu. Use always those tabs provided under modeling tab or page. Load and definition can also be reached here. Those 4 icons provided by the toolbar are also useful, but in order not to forget the order of doing things necessary for analysis of our structure, it's better follow every tab, starting from left tab and then going downwards, and also for the sub tabs, again starting from the top tab and following downwards and clicking on the other tabs which are down. And from the support tab I can reach to this load and definition dialog box. I can add new loads to here. Okay, primary loads, for example, that or live loads, and under those loads I can add member load, nodal load, and some other loads. My aim is here not to represent every load. My aim is here just to show how those tabs are used, and load and definition, and then material. Now here you see that a table showing the constants of each material, and we see here isotropic material, whole structure. All materials are here. Create isotropic material. Oh, I didn't see that. You can reach to that from here. You don't need to go to geometry and add beam and add plate. From add beam and add plate, you can reach this create new material from here. I don't know that. I recognize it now. For example, math beams, you can edit it from here. You can edit its values. Values of steel. It's not editable as I see. It's a default material as I understand. Okay, those values are default. Then you can delete them. For example, okay, now I learned its place. For example, I don't need math 1 anymore. Instead of that, I created math beams. I can delete it. Math 2, I can delete it. Okay, oh, I did a mistake. Sorry about it. I learned there's a place to delete and to recreate or to edit the materials in this program. And it's better using really this model page and subtabs beneath it. And after general, we reach to the analysis and print. Here we have closed it. It's analysis tab. We have in pre-analysis, before analysis print. Before analysis, what do we want to be printed? Problem statistics, joint coordinates, member information, support information. Before analysis, if I want those information are printed in my output file, for example, support information or element information, let's say, I click here add, print element information. You see here, solid information for solid element, member properties, click add all those information in the output file before making the analysis, support information, material properties, add all of them, okay? And then you have to select them, print element information or every element, assign it to view, you can say, and then you can click on assign every element, print element information, assign to view. Yes. That's okay. Print element information solid, print member properties, assign to members which are in the view, print material properties, okay, print element information. Maybe this is for plate elements. If assigned to view, I think this might be for plate elements. Let's delete this. It's just an information which is put in my output file before analysis. Actually, they're not required. And analysis, make analysis. In the analysis, we have to add this command also. Print nothing to do out. This means perform analysis means that make linear analysis. Okay. This means make nonlinear analysis. For example, I will not speak about other types of analysis. I will speak about linear elastic analysis, the easiest one. When I click on this tab, means that I will make a linear analysis. This is the first thing. The second thing, in my output data, I want nothing, no print. Okay? But in my output file, I may want some information like load data, statics load, mode shapes, both, all. No print means no information. For other options, if I click on them, I will get some more information in my output file. Output file is not necessary, I think, because all results I obtain during the analysis are saved to the Staad file database, and by means of query or graphical user interface tools, I can obtain nodal displacements, reaction, support forces, support moments, several things. So it's not important for me to write many things in the output files related to the results, output values, or input values. Input values, nodal, node coordinates or nodes, and material properties. I don't need to write them to the output file. It's better to click on no print so that no information, no unrequired information is written to the output file. And I will make linear elastic analysis. Say okay. Perform analysis. Perform analysis. Do you remember we were clicking here and then analysis and perform analysis. This is the same thing. Okay. If I click here, analysis, perform analysis. Okay, no print. The command will be written here 2 times, which is not good. And the program many times warned me. There is a repetition of the same command. Please delete it. Now I deleted it. And analysis, define commands, or analysis from here. Okay. After analysis, print. After making analysis, print some data to the output file. Post print. So, define commands. After analysis, I have just one load case. For this load case, you can write load list in your output file. You can write joint displacement, member forces, many things. Story drift, maximum force, but I don't want that they are written to the file. Now load list is added 2 times. Joint displacement, member forces, support reactions, close. Print joint displacements or every joint. Yeah, assign to selected node. Okay. Post analysis. Everything's okay. Now let's run analysis. Now just look here. We have 2 separate structures. Check multiple structure. We have 2 structures. Okay. It's a mistake, an unwanted thing by Staad program, but it makes the analysis. Okay, stay in the modeling mode. Okay, post processing. For this load case, give me the results. Give me the deflected shape. It's okay. Oh, I didn't show you from where I applied the forces. I just one load case. I didn't show you. My intention is just to show in this video how to use the model page instead of command menu. And it's correct to use model page, as you understand from this video. Many things are really given under modeling page. Everything is provided under modeling page. Here many things are not provided and it's confusing. I was confused. I didn't know where to obtain this material create and material delete or edit option. It was here under general tab, under material tab here. That's good. Yeah, I think it's finished in this video. I tried to show the way another thing, math solid is assigned to this assigned to selected solids. For example, assigned steel is here. Let's select the solid. As you see, now steel material is assigned to the solid. Instead of that property. So I made a mistake. I told wrong. There was a way to assign material properties also to the solid materials. Here from you can make it. This is only for materials. You can separate the without thinking go sectional properties. Only you can assign any material, create any material property and assign it to one-dimensional, two-dimensional, or three-dimensional members. Okay. Now again, math solid. Assign math solid. I have assigned it back. You can also create to orthotropic material in two directions, x and y directions, which has two different elasticity modulus perpendicular in directions perpendicular to each other. Something like that. Okay, very enjoyable video. Sorry about the mistakes I made at the beginning of the video. As a result, I suggest instead of using commands menu, just if you are making dynamic analysis, you can click on this and you can change maybe some values under miscellaneous submenu, and other that do not touch anything under commands menu. Use always commands provided here by the tabs and subtabs.